6571. If an increase in power tends to make the nose of an airplane rise, this is the result of the A. Line of thrust being below the center of gravity. B. Center of lift being ahead of the center of gravity. C. Center of lift and center of gravity being collocated. The correct answer is A. When an increase in power tends to make the nose of an airplane rise, it is a result of the line of thrust being below the center of gravity. This situation creates a moment or torque that causes the nose of the airplane to pitch upward. To understand this, let's consider the forces and moments acting on an airplane. The center of gravity, CG, is the point at which the weight of the airplane is concentrated. The line of thrust is the direction in which the engine or propulsion system is exerting force. When the line of thrust is below the center of gravity, it creates a couple or torque that tends to rotate the airplane. The downward force of the weight acts through the CG, while the upward force of the thrust acts below the CG. This creates a moment that causes the nose of the airplane to pitch upward. In contrast, if the line of thrust were above the center of gravity, it would create a moment that tends to make the nose of the airplane pitch downward. The center of lift being ahead of the center of gravity or the center of lift and center of gravity being collocated are not the primary factors that cause the nose to rise in this situation. 6510. How can a pilot increase the rate of turn and decrease the radius at the same time? A. Shallow the bank and increase airspeed. B. Steepen the bank and decrease airspeed. C. Steepen the bank and increase airspeed. The correct answer is B. To understand why this is the correct choice, let's consider the factors that affect the rate of turn and the radius of the turn in an airplane. The rate of turn is primarily influenced by the bank angle, the angle between the airplane's wings and the horizon. Increasing the bank angle increases the rate of turn, while decreasing the bank angle decreases the rate of turn. So, to increase the rate of turn, we need to steepen the bank angle. The radius of the turn is mainly influenced by the airspeed. Increasing the airspeed will result in a larger turn radius, while decreasing the airspeed will lead to a smaller turn radius. So, to decrease the radius of the turn, we need to decrease the airspeed. Combining these two factors, the pilot can increase the rate of turn and decrease the radius of the turn simultaneously by steepening the bank angle and decreasing the airspeed. Steepening the bank angle will increase the rate of turn, and decreasing the airspeed will reduce the turn radius. 6530. As the angle of bank is increased, the vertical component of lift A. Increases and the sink rate increases. B. Decreases and the sink rate increases. C. Increases and the sink rate decreases. The correct answer is B. When an aircraft is in a bank turn, the lift generated by the wings can be resolved into two components, the vertical component and the horizontal component. The vertical component of lift opposes gravity and supports the weight of the aircraft, while the horizontal component provides the centripetal force necessary for the turn. As the angle of bank is increased, the vertical component of lift decreases. This is because a portion of the total lift is now acting in the horizontal direction to provide the centripetal force. Since the vertical component of lift is reduced, the opposing force to gravity is also reduced, causing the aircraft to descend or sink. Additionally, the increased angle of bank increases the load factor on the aircraft. The load factor is the ratio of the lift to the weight of the aircraft. A higher load factor increases the stall speed of the aircraft, which means a higher airspeed is required to maintain level flight. However, if the pilot maintains a constant airspeed during a bank turn, the aircraft's angle of attack will be increased, approaching or exceeding the critical angle of attack, which can result in an increased sink rate and a potential stall. 6532. What action is necessary to make an aircraft turn? A. Yaw the aircraft. B. Change the direction of lift. C. Change the direction of thrust. The correct answer is B. When an aircraft is in straight and level flight, the lift generated by the wings is acting perpendicular to the direction of motion, providing the necessary upward force to counteract the aircraft's weight. In order to initiate a turn, the pilot needs to change the direction of lift. To make the aircraft turn, the pilot applies a control input, such as using the ailerons to bank the aircraft. By banking the aircraft, the direction of lift is tilted or inclined towards the inside of the turn. This change in the direction of lift creates a horizontal component of lift that acts towards the center of the turn. This horizontal component, along with the aircraft's inertia, results in a curved flight path, initiating the turn. It's important to note that while changing the direction of lift is necessary to initiate a turn, other factors such as coordinated control inputs, use of rudder for yaw control, and appropriate throttle adjustments are also important to maintain balance and control during the turn. So, in summary, changing the direction of lift is the necessary action to make an aircraft turn. 6507. When considering the forces acting upon an airplane in straight and level flight at constant airspeed, which statement is correct? A. Weight always acts vertically toward the center of the Earth. B. Thrust always acts forward parallel to the relative wind and is greater than drag. C. Lift always acts perpendicular to the longitudinal axis of the wing and is greater than weight. The correct answer is A. Weight is the force experienced by an object due to the gravitational pull of the Earth. In the case of an airplane in straight and level flight at constant airspeed, the weight of the airplane is always directed vertically downward towards the center of the Earth. This is because gravity acts in a vertical direction, pulling all objects towards the Earth's center. In straight and level flight, the other forces acting upon the airplane are balanced so that the net force is zero, allowing the airplane to maintain a constant altitude and airspeed. The four main forces acting on an airplane in straight and level flight are weight, lift, thrust, and drag. Weight, as mentioned before, is always directed vertically downward. It is the force that opposes lift and is determined by the mass of the airplane and the acceleration due to gravity. Lift is the upward force generated by the wings of the airplane as a result of the airflow over them. Lift acts perpendicular to the longitudinal axis of the wing, which is typically parallel to the horizon in straight and level flight. However, lift can vary in magnitude depending on the angle of attack and the airspeed of the airplane. In straight and level flight, lift is equal to the weight of the airplane, creating a balanced force situation. Thrust is the force produced by the engines of the airplane, propelling it forward. Thrust acts parallel to the relative wind, which is the airflow created by the airplane's forward motion. In order for the airplane to maintain a constant airspeed, thrust must be equal to drag. Drag is the resistance encountered by the airplane as it moves through the air. It acts opposite to the direction of motion and is caused by various factors such as air resistance, skin friction, and induced drag. In straight and level flight at a constant airspeed, drag is equal to thrust, ensuring a balanced force situation. So, in summary, the correct statement weight always acts vertically toward the center of the Earth holds true because weight is the force exerted due to gravity and is directed vertically downward. In straight and level flight, weight is balanced by the other forces acting on the airplane, namely lift, thrust, and drag, to maintain a state of equilibrium and enable the airplane to maintain a constant altitude and airspeed.